You are welcome to Kokuari E-Learning Center. I'm your facilitator, Buamon Kinsley. Today, we are still continuing on the indices for SHS1. So still the topic is indices, continuation from where we ended the last time. As I said, below is my WhatsApp contact number. So if you have any problem, you can WhatsApp me or you can call me and then we discuss it. Last, I gave you some try questions for you to try them. So let's go through the questions and see how you were supposed to solve the questions. So for the question number 1, you have 1 over 64 all raised to power negative 5 over 6. As I told you, it is very impossible with that calculator to solve additional equations with negative exponents. So first you have to make the exponent to be positive. How do you make the exponent to be positive? Unless you turn the number. So you reciprocate the number 1 over 64 and you get 64. The moment you reciprocate it, the exponent, the sign of the exponent will change. So instead of negative 5 over 6, now turns to 5 over 6. Fine. So now move on. You see that 64 is the same as 2 raised to power 6. So from the third law, you know that this is the same as 6 times 5 over 6. And the 6 will cancel the 6, you have 2 raised to power 5. What 2 raised to power 5 is what? 32. So this is what we were expecting, the answer that you were expecting. Let's do the question number 2. Question number 2, we have 9 raised to power 1 over 3 times 27 raised to power negative 1 over 2 all over 3 raised to power 1 over negative 1 over 6 times 3 raised to power negative 2 over 3. The same idea. I'm changing all the exponents which are negative to positives. So how do you change them? If it is a denominator and it becomes a numerator, the sign of the exponent will change. So all those with negative exponents, I will change their positions. If you are a numerator, you become a denominator. If you are a denominator, you become a numerator, and your exponent will change to positive. So going through it, you see that I have 9 raised to power 1 over 3. It is a positive integer, exponent, so I'll keep it. But I'll come here, I have 3 raised to power 1 negative 1 over 6. So I will change it to a denominator. The moment it becomes a numerator, then the negative sign will go to become a positive sign. Then 3 raised to power negative 2 over 3. This also is a denominator. The moment it changes to a numerator, the sign of the exponent will change. I have also 27 raised to power negative 1 over 2. It is a numerator. So the moment it changes, the sign of the exponent will change to become 27 raised to power 1 over 2. I will then try to simplify them to make them equal base. Equal base. So we know that 9 is the same as 3 raised to power 2. Then 27 is the same as 3 raised to power 3. So see that this 2 is multiplying 1 over 3. And this 3 too is multiplying 1 over 2. So see that 2 times 1 over 3 will give me 2 over 3. Times 1 over 3 times 3 raised to power 2 over 3. All over 3 raised to power. This 3 times 1 over 2 will give me 3 over 2. So see that this time the bases are the same. 3, 3, 3, 3, 3. This is multiplying. Those multiplying, we add the exponents. And those dividing, we subtract the exponents. So you see that I have 2 over 3 plus 1 over 6 plus 2 over 3 minus 3 over 2. Because these are multiplications and these are division. That is why I'm subtracting the exponent. So when you combine this, then you are going to get 3 raised to power 0. And you have got to know that anything raised to power 0 is equal to 1. Let's look at the question number 3. The same idea. I have a negative exponent. And you have a negative exponent, then I have to make it a positive exponent by reciprocate the number. So 4 over 9 now turns to 9 over 4, all raised to power 3 over 2. Because I have reciprocates the value, then the exponent, the sign of the exponent will do what? Change. What is 9? 9 is the same as 3 raised to power 2. 4 2 is the same as 2 raised to power 2. So we got to know that from some of the properties. If 3 raised to power 2, 2 raised to power, then it's the same as 3 over 2, all raised to power 2. So that 2 will cancel these 2, so I have all of them raised to power 3. So all this is the same as 3 raised to power 3 and then 2 raised to power 3. So 3 raised to power 3 is 27, 2 raised to power 3 is 8. That is what we are also expecting you to get an answer. I hope you all got it right. Now let's look at today's lesson. For at the end of today's lesson, students will be able to solve exponential equations. So we are now going to look at exponential equations. That's the equations, indices involved with the equations. How do you solve them? That is what we are going to look at today. Before you do that, then let's look at this. If you have a raised to power m is equal to a raised to power n, all this is equal to this, then we are saying that for mathematics this can only be possible if the m2 is equal to n, else this can never be possible. So if a raised to power m is equal to a raised to power n, the moment the bases are equal, then the exponent too should be equal, else they cannot be equal. So we are saying that if a raised to power m is equal to a raised to power n, then m is equal to n. Also, if you have a raised to power x is equal to b raised to power x, so you see that this time to the exponents are equal, xx, and this can only be true unless a is equal to what? B. So this is the main basics that we are going to use to solve exponential equations. So we are going to use that to solve these questions. So we have 1, 2, 3, 4, 5 questions. So what it takes is, if I have exponential equation, if it is possible, then one side will raise to the power of one base, and then the other side will raise to the power to the same base. Then I can compare the exponents. Or I'll have exponents which are equal, then I can compare the bases. So we are going to use that idea and see how to use to solve question 1, 2, 3, 4, and 5. So let's look at question number 1. Say we should solve 3 raised to power x squared minus 1 equal to 9 raised to power 4. We want to find the value of x. So I'm giving you, what is 9? Try to raise 9 also to 3 raised to power something. So I hope you are able to make it. So the 9 is the same as what? 3 raised to power 2. All this is raised to power 4. So what do? You got to know that if all this is raised to power 4, then it's the same as 2 times 4. So we have 3 raised to power x squared minus 1 is equal to 3 raised to power 8. What do you see? You see that the bases are the same. This is equal to this. The base is 3, the base is 3. If this is true, then the x squared minus 1 should also be equal to what? 8. So we now have this simple equation. Then you solve this simple equation. So we are now going to get x squared is equal to 9 by grouping like terms. Then you square root both sides. Know that when you square root a number, it's either positive or negative of the answer. So x is equal to either positive or negative of root 9. So what is x? So x is either plus or negative of what? 3. Thank you. Let's move on to the question number 2. Question number 2, I'm going to leave you with just 5 seconds or 10 seconds for you to see if what we did at question number, you can apply the same thing and solve the question number 2. Thank you. Let's see how, I hope you are able to solve it. Let's see how I'm expecting you to solve the question. Fine. So what is 8? 8 is the same as 2 raised, because this is 2. So we are trying to say, okay, 8 is also 2 raised to power 3. So this 3 is multiplying the exponent also over here. Now these 2, the bases are the same, 2, 2. So what do? You equate the exponents. So we have this 3 going into x minus 2 is equal to x minus 8. Then you solve this simple equation. So you bring the bracket, and then you group like terms, and then you combine the like terms, and then you divide both sides by the coefficient of the variable, and get x is equal to negative 1. Let's look at question number 3. I'm also giving you about 20 seconds to see how we can also apply what we are saying at the question number Good. I hope you have finished. So let's look at the question number 3. What is 125? You can say 125 is the same as 5 raised to power something. So this is the same as 5 raised to power 3. And what is root of into root of 5 raised to power 4x minus 7? Last time I told you that root of any number is the same thing raised to power half. So all this thing is raised to power half. Good. So what do you see here? So what all this is, you are raising a certain value to all the third law to a n raised to power all n. It means that you multiply the exponents. So it means that this 1/2 is multiplying the 4x minus 7. So see that the 1/2 is multiplying the 4x minus 7. Now what you see that the bases are the same now. You have 5 and 5. So we can now equate the exponents. So we now equate the exponents. So we have 3 into x minus 3 equal to half also into 4x minus 7. So what you have to do is solve this simple equation. So first calculate the fraction from there and you get this. After calculating the fraction, then you can open the brackets by multiplying through by the 6 and get this one. Then you group like terms. 6x minus 4x is equal to 18 minus 7. Then you combine like terms to get 2x is equal to 11. So you will see that s is equal to 11/2. Let's look at the question number 4. You see that the question number 4 is a little bit different from question 1, 2, and 3. See that this one we have additions and subtractions inside with index over there. So what you have to do is you look at the index. The radical value is the 3 raised to power x. So what you have to do, you have to manipulate and make all look at 3 raised to power x and something. So when you look at this, multiplication is commutative. 2 times x is the same as s times 2. So this one I can write it as, I can write the 3 distance as 3 raised to power x all raised to power 2. It means that the x is multiplying the 2, which is the same as the 2x. So you see that I have arranged it as a radical 3 raised to power x. This is 3 raised to power x. So what I'm going to do is I will equate the 3 raised to power x by a certain variable. So I'm saying let the 3 raised to power x to be equal to y. So wherever I see 3 raised to power x, I'm going to write y in the equation. So I'm going to get y squared minus 30y plus 81. So I have turned this one to a quadratic equation now. So I've then solved this quadratic equation. I want two numbers multiplied to give me 81. I want to add this to be negative 30. The negative 3 and negative 27. So you see that I'm going to get y minus 27, y minus 3 equal to 0. So in this case, you see that y minus 27 is equal to 0 and y minus 3 is equal to 0. So my y is 27 or 3. But mind you, we are not solving for y, so we have not finished. We are solving for x. So we let the y to be equal to 3 raised to power x. So the moment we get our y to equal to 27 and 3, then we want to find x when the y is 27 and when y is also equal to 3. By using what we have done over here. So you move on and see that, okay, when y is equal to 27, you know that the 3 raised to power x is now equal to what? 27. Now we have come back to what we were doing at question number 1, 2, and 3. So we see that 27 is the same as 3 raised to power 3. Now we see that the bases are the same now, 3, 3. So the s is equal to 3. Also, when y2 is equal to 3, you see that you have 3s2 is equal to 3. So you see that the bases are the same, 3, 3. 3 is the same as 3 raised to power 1. So you see that s is equal to 1. Hope you have understood. Thank you. Let's look at the question number 5. I have only bring the question number 5 over here for you. So see that is 2 raised to power 2s plus 2 minus 9 raised to power 2x. 9 times 2 raised to power x plus 2 equal to 0. So I decided to break this into what I was doing at the question number 4. So you see that 2 raised to power 2 is the same as 2 raised to power x, all raised to power 2, but the x is multiplying the 2. You see that this is plus 2. Plus 2 means 2 raised to power 2 is multiplying 2 raised to power 2x. That is what I have done over here. So this is 2 raised to power 2, which is this one. So you see that the bases are the same. If I'm doing it, it's 2 plus x times 2, or 2 times x, which is 2x plus 2, is the same thing. So I have just simplified this one as 2 raised to power 2 into 2 raised to power x, all raised to power 2, minus 9 raised to power 2x plus 2 equal to 0. So what is 2 raised to power 2 is 4. So this is 4. But first, you can decide to make the 2 raised to power x to equal to y. So wherever I see 2 raised to power x, I'm going to put y over there. So 2 raised to power 2 is 4. So this is y. So it becomes y squared minus 9y plus 2 equal to 0. Then this is the quadratic equation. So you try to solve this quadratic equation. I know you know how to solve quadratic equation. So I'm just waiting for you to solve this quadratic equation. I hope you are finished solving the quadratic equation. So what am I expecting? I'm expecting the factors of the quadratic equation to be y minus 2 all into y minus y over 4 equal to 0. So you solve for this and say y minus 2 is equal to 0, and then y minus 1 over 4 is also equal to 0. So you get y is equal to 2 and y is equal to 1 over 4. But as I said, we are not solving for y, we are solving for what? X. So you now compare the 2 raised to power x and then the y. So say when y is equal to 2, what will be x? And you see that we're going to get 2 raised to power x is equal to 2. So 2, the exponents, then you compare the exponents, x and 1. So x is equal to 1. When y2 is equal to 1 over 4, then you see that we are going to have the 2 raised to power x also equal to 1 over 4. What is 4? 4 is the same as 2 raised to power 2. So the moment you want the bases to be the same, 2, then you are changing the base, you're changing the position of the exponent. The moment you change the position, the exponent will do what? Change. So it is a denominator. So the moment you change it to become a numerator, the exponent, the sign of the exponent will change to negative. So we compare the exponents. Now 2. So we see that x is equal to negative 2. I hope it is well understood. Now what have we done today? We have got to know that if I have a raised to power m equal to a raised to power n, then m is equal to n. Or if I have a raised to power x equal to b raised to power x, then we are saying that a is equal to b. I want you to go and try and see if you can use what you have done so far to solve the following questions. The questions are here. So you copy them and then try your own on your own, and let's see how you can solve these questions. When I come next time, you look at how to solve these questions. As I said, I have my WhatsApp contact number over here. So if you have any problem, you can call me or you can WhatsApp me, and then we discuss it, especially on the topic indices. Thank you very much, and I hope to see you next time. Bye bye.